Welcome back to Remote Sensing Applications using ArcGIS. In this session, what we're going to do is co-register a historic aerial photograph with this UTM raster of the Tanana River. So if we symbolize our UTM raster, we'll symbolize it as 2 standard deviations stretch and then just OK. And then we'll add an aerial photograph from 1978. And this aerial photograph is simply a scanned aerial photograph, so it has an unknown coordinate system. So then just OK. And then right mouse click zoom to layer. So here's our color infrared photograph from 1978. And what we want to do is co-register it to our UTM image such that they will match. So let's say this UTM image is from last summer and this color error photo is from 1978. So the first step is we'll set our target to the 1978 color infrared photograph. And then what we'll do is we'll quickly establish 4 control points, and with georeferencing auto adjust on, it will use those 4 control points and automatically adjust our color infrared photograph from 1978 using the model based on those 4 control points. Okay, so we established 4 control points. Here's a control point number 1, a control point number 2, control point number 3, and a control point number 4. And with those 4 control points established, since we have georeferencing auto adjust on, if we zoom in, the images will be roughly co-registered. So here's a 1978 image, and here's the UTM image from last summer. So they're roughly co-registered. So now your job is to fine-tune and add 10 control points such that you're as closely as possible pointing to the same location on the ground in 1978 as there is in last summer's image. So add 10 more control points, and then we'll delete the 4 initial control points. Okay, so we want all our control points on a flat surface of the floodplain, so basically along the Tanana River. And at this point, I've got 9 control points in addition to my 4 initial rough control points. So we'll just do one more. So we'll zoom on in an area. We want our control points well distributed. So let's go in this area right here. So this is 1978, and this is 2013 last summer. So basically we need to find the same location in 1978. So maybe this location. And where is that location in the 2013? So it's probably about right there. Okay, so now we've got our 10 control points. So if you look at your link table, we'll delete the first 4 initial control points. So we're going to delete the 4 initial control points. So this one, press the delete key. 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 So now we've got 10 links, and the root mean squared error is about 12 meters. So what we want to do is develop a model with at least 10 links and the root mean squared error of 10 meters or less. So we'll add some more links and then delete the links that have the highest residual error. Okay, so I have a total of 20 links, and what I'll do is I'll delete the ones with the highest residual error. So here's my one with the highest residual error of 29 meters. So what I'm going to do is delete 5 of the 20 links and then see with 15 links, do I have a root mean square error less than 10? So I'll delete the one with the highest residual error, next one, and next one. Okay, so now my residual error is less than 10, and I've got a total of 15 links. So I've satisfied my criteria, so now what I'll do is georeferencing, update georeferencing. And that saves the model based on these 15 links to the world file. Okay, so then if you go to the Blackboard website, I've got a quiz question on your co-registered 1978 image after you've updated georeferencing with a model that has a root mean squared error of less than 10 meters based on 15 links or more.